Hi there! You might have found yourself wondering why earthquakes happen, or how the Earth's surface developed from Pangaea days to the 7 continents we know today. All of this has to do with something called plate tectonics.
The plate tectonic theory, developed by Alfred Wegener, tells us that the Earth's outer layer, the lithosphere, is actually broken into several chunks and pieces, which we call plates. The plates are constantly moving about a few centimeters a year, and over millions of years have shifted to form the way we know the Earth to look today.
Plates are classified into oceanic or continental, depending on which one they hold. Over time, the way plates move at their boundaries has formed the land and water forms we know today. So how do plates move at their boundaries?
Plate boundaries can be classified into convergent, divergent, and transform. At convergent boundaries, plates push toward each other. Divergent is the opposite. Plates move away from each other. At transform boundaries, plates slide past each other in opposite directions.
All of this pushing, separating, and sliding has formed many things such as mountain ranges, lakes, underwater volcanoes, and of course, the way the continents look now.
But on a smaller scale, how does all of this affect us? Well, you might remember how I mentioned earthquakes earlier, and plate tectonics have a lot to do with how earthquakes happen. It can all be explained by something called the elastic rebound theory.
The theory was developed by Harry Fielding Reid. It happens like this. The movement of plates puts stress on rocks, causing a buildup of strain and elastic potential energy. Eventually, the elastic limit of these rocks is reached, and they rupture, slip, or snap, releasing the built-up energy in seismic waves.
The point where the slippage happens is called the focus, and the point on the Earth's surface directly above it is called the epicenter. When the seismic waves reach the epicenter, we feel the earthquake.
We know that earthquakes can get really destructive. Earthquakes are measured in a number of ways: by their intensity, magnitude, or total strain energy release. The intensity scale is more useful in places where a lot of damage can be observed. The moment magnitude scale, which measures total strain energy, is useful for very strong earthquakes.
The one you probably see most and often in the news is an earthquake's magnitude, measured using the Richter scale. Knowing how strong an earthquake is can help you know what earthquake-related hazards to be ready for.
Aftershocks are expected, especially after a shallow main shock. Be wary of fires, structural damage, and ground displacement. Underwater earthquakes can also trigger tsunamis because of the sudden volume displacement caused by the shock.
Landslides can also happen after earthquakes due to liquefaction. Liquefaction is when sandy earth layers act like liquids under pressure from earthquakes. This makes the ground unstable and susceptible to landslides.
But keep in mind that earthquakes aren't the only hazardous things that can be caused by plate tectonics. Remember how we mentioned that plate movement also forms landforms such as volcanoes? That makes volcanic eruptions just one of the numerous other geology-related hazards to be aware of.
Knowledge of geology and geology-related hazards can be an incredibly important part of our daily lives. Disaster awareness and preparedness is essential in being ready to deal with possible hazardous events. Even those in the ranks are always ready for what can happen.
Siyempre, para madagdagan yung kaalaman natin kung paano natin i-deploy yung mga sa safe na area. Yung safety natin na
Do your best to be aware of what to do in preparation for, during, and after a geology-related hazard event. That's it for plate tectonics for today. Be informed, be safe, and thanks for watching.